We have four properties of logarithms. The first property, we have log m times n with a base b. If we multiply inside logarithms, we can split it up to two logs, log m plus log n, and both logs will have the same original base of b. Second property is dividing. If you're dividing inside logarithms, m divided by n, we can split it up to two logs. We'll have log m minus log n, and again, both with the same original base, base b. The third property involves exponents. If you have an exponent inside the logarithm, we can actually bring that exponent to the outside, and we'll be multiplying p times log m with the original base of b. And last property, if you have log of b, base b, so you have the same number inside the log, that's the same number as the base, those will cancel, and you'll have just one without any logs. Title of the first section today is Expanding Logarithms. In this section, we'll use the properties of logarithms to expand the logs. First question is log 3x base 4. This logarithm has a multiplication inside, 3 times x. Looking back at the properties of logarithms, multiplication we can change to two logs. We'll have log with the base 4, 3. And instead of times x, we'll add to that a second log with the same base with x on the inside. So log 3x base 4 is equal to log 3 base 4 plus log x base 4. Second question is log x divided by 2 with a base of 6. Again, dividing inside logarithms. If you're looking back at the properties, we'll change this to a subtraction question. Log with the numerator x, base 6, and we'll subtract a log of the denominator, which will be log 2, the same base, base 6. And last question for the section, log x squared with the base 10. If we have exponents, again this exponent we can move to the outside, be multiplying by 2 times the log of x base 10. Title of the next section is Approximate Values of Logarithms. In this section we'll use given values for some logarithms and approximate the values of other logarithms. First question, if log 2 base 5 is approximately 0.4307 and a second log, log 3 base 5, is approximately 0.6826, we'll find the value of logarithm 4/3 base 5. These logs are approximated. If you use a calculator to actually find the decimal will continue on. These decimals are approximated or rounded off to 4 decimal places. Solving the first question, log 5 of 4/3 base 5. What we want to do is change this into logs using log 2 and log 3, which will both have log 5. First we can rewrite log 5, and instead of 4/3, we can actually take the log of the first number, and since we're dividing, subtract the log of the second number. So we'll have log 4 base 5 and minus log base 5 of 3. The second log, we have the decimal for, log 3 base 5, but the first log, we have log 4, which is not given in the question. What we can do to solve, though, is log 4. If you think of 4 as 2 times 2, we're given the log of 2, so if we change this to 2 times 2, we'll be able to use the decimal given. So rewriting this expression again, if we have log 2 times 2, the multiplication property again, we can split up into 2 logs. We'll have log of the first 2, base 5, and adding to that, a second log of 2 base 5. And the last log will stay the same, minus log 3 base 5. So rewriting 4 over 3, we can expand this and write this as 3 logarithms. Each of these were given a decimal for at the beginning of the question. Log 2 base 5 is approximately 0.4307. And the second log is the same value, 0.4307. And we'll be subtracting log 3 base 5, which again is given in the original question as 0.6826. Combine these decimals, adding and then subtracting, we'll be left with our final answer of 0.1788. So by expanding logarithms and using given information, we can estimate that log 4 over 3 base 5 is approximately 0.1788. Second question, and last question for the section. Again, we'll approximate the value of the log. This time we'll have log 50 base 5. To approximate again, we need to change 50 into the given numbers that we had before. Using the properties, we can change 50 into several numbers. For example, if we write out 50 as 5 times 10, we'll have log 5 base 5 and log 10 base 5. The 10 we can also write out as 5 times 2. So 50 will be the same as 5 times 5 times 2. Since this is all multiplication, we can change this using the properties to the addition of 3 logs. We'll have log 5 base 5 plus the second number being multiplied, which would be log 5 base 5, and plus the last log, which would be log 2 base 5. Looking back at the given information, log 2 base 5 is given as a decimal. Log 5 base 5 and log 5 base 5 are not given. But looking back at the properties that we wrote at the beginning of the section, if you have the same number and the same base, this is equal to 1. So log 5 base 5 is equal to 1, and the second log is the same. Log 5 base 5 is equal to 1. The third log, again, the original decimal for log 2 base 5 was approximately 0.4307. Adding together 1 plus a decimal, our final answer would be 2.4307. So approximating log 50 base 5 with the given information is approximately 2.4307. Title of the last section today is Solving Equations with Logarithms. In this section, we'll solve equations that have logarithms inside the equations. First question we'll solve is log 5 base 3 plus log x base 3 equals log 10 base 3. To solve questions that contain logarithms or multiple logarithms, using the properties, we can actually combine these into one logarithm. If we have log 5 base 3 plus log x base 3, using the addition property, instead of adding two logs, we can combine these together to make one log, which will have the same base 3, but instead of 5 plus x, we'll change the addition to multiplication, so it'll be 5 times x, or 5x. Equals a single log on the right hand side, log 10 base 3. Solving logarithms, if you have a single log on each side that has the same base, we can cancel out or ignore those. Since the logs are equal and the bases are equal, if the numbers or terms inside the logs are equal, then the equation would be equal. So we'll be left with 5x equals 10. Solving from here, dividing by 5, we'll have the answer of x equals 2. Second question, and last question for the section. 2 times log 10, or base 10, 6. So 2 times log 6 base 10 minus 1/3 log 27 base 10 equals log x base 10. Again, solving questions with multiple logarithms, we want to combine all logs together, so we have a single log on each side, which will have the same base of 10. Looking at the first logarithm, we have 2 times a log 6 base 10. Instead of multiplying by 2, we can use the properties of logarithms, and the 2 we can bring inside as a exponent. So rewriting, we'll have log 6 to the second power base 10. Multiplication on the outside, we can bring inside for an exponent. And then minus, same thing with the second log. For multiplying by 1/3, we can bring this 1/3 on the inside. The log would stay the same, the base would stay the same, but we'll have 27 to the exponent of 1/3 equals the same log, log x base 10. Simplifying further, the log and the base would stay the same. 6 to the second power, we can rewrite as 36, minus the second log and base would stay the same. 27 to the 1/3 power. If you remember fractional exponents from previous sections, this is basically taking a radical. The 27 would stay on the inside. The numerator 1 would be the exponent, 27 to the first power, and the 3 would be the root number. So 27 to the 1/3 power is the same as a cube root of 27, or a number times itself 3 times its 27, and that number would be 3. So 27 to the 1/3 power is the same as 3. Equals log x base 10. Simplifying once more, now we have a single log with no numbers outside. The subtraction we can change into a single log. 36 divided by 3. And the base 10 would stay the same. Equals the same log, log 10 base x. After simplifying and combining logs, we're left with a single log on both sides, the same bases. So again, we can cross those off or ignore those since those are equal, and the numbers or terms inside should be equal also. 36 divided by 3 would equal x, or simplifying, we'll have 12 equals x, or x equals 12.